Okay, chapter 9.6 is modeling with trigonometric functions. The essential question in this chapter section is, what are the characteristics of the real-life problems that can be modeled by trigonometric functions? What you will learn in this chapter section is how to interpret and use frequency, write trigonometric functions, and use technology to find trigonometric models. So let's take a look at example one. Okay, let's look at the word frequency before we get started. The periodic nature of trigonometric functions makes them useful for modeling oscillating motions or repeating patterns that occur in real life. Some examples are sound waves, motion of a pendulum, the seasons of the year. In such applications, the reciprocal of the period is called the frequency, which gives the number of cycles per unit of time. So example one is using frequency. A sound consisting of a single frequency is called a pure tone. An audiometer produces pure tones to test a person's auditory functions. An audiometer produces a pure tone with a frequency f, 2000 hertz, which is cycles per second. The maximum pressure P produced from the pure tone is 2 millipascals. Write and graph a sine model that gives the pressure P as a function of the time t in seconds. So the solution in this is step one. We want to find the value of A and B in the model where P equals A times sine of B times t, where t is time, in seconds. Okay, so the maximum pressure is 2, which is right here, produces from pure tone so that's where this is coming from. Let me get the highlighter. Pure tone in 2 is 2 millipascals. So there's our pressure, 2. So that is A. That is going to be our vertical stretch. Write and graph a sine model that gives P as a function in time. All right, so use the frequency F to find B now. So frequency, remember, is 1 over the period, because frequency is the reciprocal, which it said in that definition of frequency. It is the reciprocal of the period. Okay, so that is 1 over period. So write a relationship involving frequency and period. And we know that the frequency in this situation is 2000, which is right here. Frequency F of 2000 hertz. So 2000 equals, and we know that the period is 2 pi over B. So we take the inverse, which is B over 2 pi. So far, so good. And then finally, we're going to solve by multiplying both sides by 2 pi. So they just aren't showing that, but by now we should be able to see that quickly. Let me get my pen. So what they did was they took 2 pi and multiplied both sides by 2 pi. These 2 pi's cancel. 2 pi times 2000 is 4000 pi equals B. Now the pressure P is a function of time is given by P equals 2 sine 4000 pi t. Okay, so there's our equation. A was 2, B was 4000 pi, so P equals 2 sine 4000 pi t. Then we want to graph the model. The amplitude is 2, and the period is 1 over F, which is 1 over 2000. Okay. Okay, so here's the graph. So we knew that the A is 2. So you want your Y to go up to 2 and down to -2. And we have the x-axis here, which is T, time in seconds. And we know that the period is 1 over 2000. So this would be 1 over 2000 right here. So this would be 1 over 4000. And this would be 1 over 6000. And this is 1 over 8000. Okay, so we know it goes from here to here, 1 period. The amplitude is 2. So now the intercepts are going to be 1/2 times 1/2000, comma 0. Okay, and that's coming from chapter 9.4 or 9.5, where they gave those graphs. So it's 1/2 times 1/2000, or 1/2 times your period, comma 0. So 1/2 times 2000 is 1/4000. So that's a 0. 1/2 times, that's 1/4000. So the intercepts are 0, 0, okay, because the sine of 0 is 0. 1/4000 and 1/2000. I don't have this labeled correctly. So if this is 1/2000, and this is 1/4000, and this is 0. Yeah, that's correct. Okay, so half of 4000 is 8000, and this is 1/6000. No, it's not. Can't we go back up to 6? 2, 3, 4, 5, 6, 2, 4, 6, 8. Okay, so instead of reducing, let's do it this way. Let's make this 2/8000, 3/8000, 4/8000. So 4/8000 is 1/2000. Okay, 3/8000, which can't be reduced. 2/8000 is 1/4000. Okay, that makes more sense. So the intercepts are 0, 0. 1/4000, which is 2/8000. And then 4/8000, which is 1/2000. All right, that's better. And then we take the maximums, which we take 1/4 times 2000, 1/2000, comma 2. We know the maximum is 2 because of P, or the A, equaling 2 here. So that's going to be 1/8000, comma 2, which is right here. So you go over to 1/8000, 2, and that's right there. The minimum is going to be 1/8000, comma negative 2. So 3/4 times 1/2000 is 3/8000, comma negative 2, which would be down here. So then if I were to graph all of this, it would look like that. So you go up to your maximum at 1/8000, back down to 0 at 2/8000, down to a minimum at 3/8000, and back up to 0 at 4/8000, or 1/2000. So the graph of P equals 2 sine 4 pi t is right here. Okay, and that is the sine graph of the frequency pure tone. Now you should be able to do problem number 11 in your exercises. Okay, this is example 2, working with trigonometric functions, and it's write a function for the sinusoid shown. So before I even go any further, writing a trigonometric function, it says graphs of sine and cosine functions are called sinusoids. So this is either a sine function or a cosine. It's not a tangent or a cotangent. Okay, it's not a secant. It's a sine or a cosine. One method to write a sine or cosine function that models a sinusoid is to find values of a, b, h, and k for these types of equations. So we don't know if it's a sine or a cosine yet. So we do want to find the maximums and minimums for starters. So step 1 is, what is the max? What is the min? That's the first thing you want to do. What is the maximum? Well, this goes up to the y value of 5, and it goes down to a y value of -1. So it has a midline halfway between. So the midline is k. So then we would say k equals the maximum plus the minimum divided by 2, which equals 4 divided by 2, which is 2. So I'm going to draw a midline, arrows, dashed green at 2. So my midline is right here. That's a bit thick, but that's okay. So let me just do that. That's better. Okay, so there's our midline. So at 2, we go down 1, 2, 3. We're at the minimum. We're at the midline. We go up 1, 2, 3. We're at the max. Midline is in the middle. Okay, so step 1, find the max, find the minimum, find the midline next. Okay, so that's the vertical shift k. So that is our k. So k equals 2. So now I have y equals a sine or cosine. And let's see. Let's just stop at that. I'm not going to fill that in like that. So we do have a +2 at the end. That's our k. All right, so the amplitude, absolute value of a is the amplitude. 2 pi over b is the period where b is positive. H is the horizontal shift and k is the vertical shift. So we already knew all of those things. So step 1, we found the max, we found the min, we identified the k shift on step 2. Now step 3 says to decide whether the graph should be modeled by a sine or a cosine function. So that's the third step. Step 3. So I'm going to say this was step 1, this was step 2, and step 3 is sine or cosine question mark. Okay, so step 3 is determining what goes here. Is it this or is it this? We've already found k to be 2, so I'm going to put them under here. That's how I'll do it. So we know k is 2. All right. The midline is y equals 2. And on the y-axis, right here, we're on the midline, which is a 0. Sine is 0. So if this was not shifted, it would be at the 0. So this is a sine function because on the y-axis, the midline goes, it touches the midline. So that is a 0. So therefore, h equals 0. So here is our h. So it's just going to be a -0 or just simply x. So there's not going to be an x minus something plus 2 in parentheses. Okay, so the next step is 4. What is the amplitude? And in order to find the amplitude, that's the absolute value of a, and that equals the maximum minus the min divided by 2, which is 5, minus a -1 divided by 2, which equals 6 divided by 2, or 3. In other words, to get from -1 to 5, that's a distance of 6. Amplitude is the distance from the midline up. So I also could have just started here and said, oh, 1, 2, 3. So amplitude, the absolute value of a is 3. The graph is not reflected because it's going up from my 0. So it's just 3 here. And by the way, we already determined it's a sine function, so let's ignore that now. So now we have 3 sine something x plus 2. So we're almost there. 3. So I'm going to call that y equals 3 sine, and I'm not going to put anything here yet. I need to determine the how many times it repeats. So sine, remember the unit circle. It's always a good idea to go back to the unit circle. Sine of 0 is 0. Sine of pi over 2 is 1. It's our y values. Sine of pi is 0. And sine of 3 pi over 2 is 0. So we are at 0. We go up, we go down, we come back up. Here is the end. That is one period, and it stopped at pi over 2. So the period is pi over 2. So since the period is pi over 2, that equals our 2 pi over b, which we learned in an earlier chapter. So if we have pi over 2 equals 2 pi over b, and we solve for b, we would multiply both sides by b, and we get 2 pi. Then we'd multiply both sides by 2, and we get 2b pi. Let me just put that. We'd get 2b times pi, because these 2's cancel. So it'd just be 2 pi, actually. Here, let me start over. Let me do this one more time. And let me change colors because it's not part of that. So what you want to write is pi over 2. That's our period. And that equals 2 pi over b. Okay? So if I multiply both sides by b, I'm just going to work vertically. I like it better. Then I get b times pi over 2 equals 2 pi. Multiply both sides by 2. These 2's cancel. I get b pi equals 4 pi. Divide both sides by pi. And voila, b equals 4. And we are done. Okay, so here is our answer right here. Y equals 3 sine 4x plus 2. That is the graph of this function. By doing the max min, finding k, which is our constant at the end, determining where the midline is, determining if it's a sine or cosine based on our y-intercept. Was it 0, or was it on the midline, or was it off the midline? That would be cosine if it was off, sine if it's on. Setting our period equal to 2 pi over b tells us the number after sine but before x. That's our b. So that determined y equals 3 sine 4x plus 2. That is the graph of this function right here. Okay, so now try examples or exercises, try exercises 13 and 14. Okay, example 3 is modeling circular motion. 2 people swing jump ropes as shown in the diagram. The highest point of the middle of each rope is 75 inches above the ground, and the lowest point is 3 inches above the ground. So this rope is not hitting, it's swinging and it's going 3 inches above the ground, and the rope makes 2 revolutions per second. 1, 2, and the rope is done. 2 revolutions per second, 1001, it went around twice. Write a model for the height, h in inches of a rope as a function of time, t in seconds, given that the rope is at its lowest point where t equals 0. So the rope oscillates between 3 inches and 75 inches above the ground. So a sine or cosine function may be appropriate model for the height over time. That's the first thing. So it could be sine or it could be cosine. So step 1, I'm going to write it over here. Actually, did I have it already? Nope. Okay, so step 1. Oops. Step 1. Identify the maximum and minimum values. So the maximum equals 75 inches and the minimum equals 3 inches. Okay, so that's the maximum and the minimum. Step 2, what is the height? Identify the vertical shift, vertical shift. Well, that's k equals. And k equals the max minus the min divided by 2. So that's going to equal the maximum, which is 75. I'm sorry, not minus, plus. the maximum plus the minimum, because it's not going below the ground, it's going above. Max plus the minimum divided by 2, which is 78 divided by 2, which is 39. So K equals 39. So what that means is this midline is 39 inches above the ground. So 39 inches from here, 3 plus 39 is 42. 42 plus 39 is 75. So that's halfway between 75 and 3. So that's our K. Now step 3. Step 3, we decide whether the height should be modeled by a sine or cosine function. So when time t equals 0, the height is at its minimum. So this is at its minimum at time 0. Well, it's not on the midline, so this is a cosine. Does that make sense? So we're going to use a cosine function whose graph is reflection in the x-axis with no horizontal shift. So cosine with h equal to 0. So h equals 0. No horizontal shift. So we want to find the amplitude and period next. So step 4, amplitude. Okay, amplitude is the absolute value of A equals maximum minus minimum. So be careful when you're looking for H, it's maximum plus minimum divided by 2. When you're looking for amplitude, it's maximum minus minimum divided by 2. So that's going to be 75 minus 3 divided by 2, which is 72 divided by 2. And that is going to equal 36. So the graph is a reflection in the x-axis. A is positive. So A, therefore, A equals a negative 36. Because the rope is rotating at a rate of 2 revolutions per second, 1 revolution is completed in a half a second. So the period, which is 2 pi over b equals a half or 0.5. So if I do this and I solve for b, I want to multiply both sides by 2. I'm sorry, multiply both sides by b is what I meant. Get rid of the denominator first. We're trying to get b by itself, and we don't want it in a denominator. So I'm going to multiply both sides by b. These cancel, and I get 2 pi equals b over 2. Now multiply both sides by 2, and I get b equals 4 pi. Okay, so now we have, let me highlight them. We have K is 39. We have H is 0. We have B is 4 pi. A is negative 36. Now it just all falls into place and we answer the question. So now we say Y equals A, negative 36. We decided it was cosine. B is 4 pi. H was 0. And K was 39. So the equation of this rope, skip rope spinning around is Y equals negative 36 cosine 4 pi plus 39. Okay, so now try this process with exercise 19. Okay, example 4, using sinusoidal regression. Remember, sinusoidal means graphing a sine or a cosine function. Don't think it's just sine. So the table shows the number n of hours of daylight in Denver, Colorado on the 15th day of each month, where t equals 1 represents January. So this is January 15th. Okay, 9.68 hours of daylight. February 15th, 10.75. March 15th, April, May, June, all the way through to December. So there you go. So the maximum sunlight is in June, 14.98 hours of sunlight. It says to write a model that gives n as a function t and interpret the period of its graph. So this is a calculator job. So we're going to start by solution. Step 1, enter the data into the graphing calculator. So follow me on my graphing calculator. So the first thing you want to do is turn your calculator on and press stat and leave it at edit and hit enter. If there's something there, arrow up and hit clear and come back down. We want to put 1 through 12 in our calculator. 1, 2, March, April, May, 6, July, August, 9, October, 11, December. All right. And then we're going to arrow over and we're going to put the values that we had. 9.68, 10.75, and so on. $14.70, enter. 13.73, enter. 12.45, enter. 11.17, days are getting shorter. 9.98, enter. 9.38, enter. Okay, make sure you have 12 in both columns or you get an error mismatch. We've entered all of the data into the calculator. That is step 1. Step 2 is make a scatter plot. In order to do that, we want to hit, first we want to go to second stat plot, arrow down to here and turn it on. So what I did here was second y equals to get this blue stat plot. Second y equals. Your button might be yellow, so it will say yellow stat plot. So you hit second y equals. We want to turn the plot on. And this is a scatter plot. And this is a line graph. And this is a bar graph. And these are box and whisker plots and so on. And that's a step graph. So we want this first one here. And we could either use dots or we could use little squares. I'll just leave it squares for now. It is on, so I hit enter. And then I hit graph. And as you can see, I have something in y equals. There's a line there. So I'm going to go to y equals, clear that, and hit graph again. I see my first dot, but I don't see any others. So I'm going to press zoom. And there is a command to do zoom stat, which means zoom to the statistics that we have entered in the table. So I hit zoom stat, and there is our graph, just like you see here. It just seems steeper on this one. Okay, so there is step 2, making a scatter plot. If you need to go through that again, just pause the video, back it up, play it again. On to step 3. The scatter plot appears sinusoidal. Why? Why is it sine and not cosine? Here's the y-axis. It's coming down to 0. So if it's 0 at the median line, then it's a sine. So we're going to do a sine regression. So in order to do that, we're going to do stat, calculate. Let me do that again. You press the stat button, you arrow to the right to get to calculate. Now here are all the regressions. Linear regression, quadratic regression, cubic, quartic, linear, ln, natural log, exponential regression, power regression, logistic, sine reg. So there it is right there, C. So I hit enter. Okay, and all I'm going to do is enter through this. I'm not going to change anything here, and I'm going to hit, and I'm going to get these values. And notice they match 2.7647344198, 5111, negative 1.59, 12.13, blah, blah, blah. So this matched this step. So that's how you do that. Okay, if you need to go through those steps again, just back the video up. I'm going to continue to step 4. Graph the data model in the same viewing window. So now that I have this, I'm now going to go to y equals.
I want that function right here. So there's no copy paste in the calculator. Well, there is, but it's not just Control C, Control V. You have to press the vars button. You have to go to 5 for statistics. And then you have to arrow over to EQ. And we want that sinusoidal regression equation. So you put it there, and it put the sine equation in Y1. And now when I hit graph, the function goes through those points. It is a really good fit for that. And there it is. So that's the graph of the model. So the model appears to be a good fit because those points are on the line. Okay. So n equals 2.76. Now, if I go back and if I hit stat calculate, it was C. So I'm just going to quickly go to alpha and ABC. Where is C up here? It's right here. So there's a sinusoidal. If I just go through it again and I look at it, then I should write these values down when it does that. So A, let me get a pen. A is approximately 2.765. B was 0.5112. C was approximately, that should be approximately. C was negative 1.591. And D is approximately 12.133, just going out 3 decimal places. Okay, so that's where all this comes from. So the data is n equals 2.76. That's my A. Sine, B was 0.511. I have 2. They rounded to 2 places. T minus 1.59, which is C, plus D, which is 12.133. So that's where all these values came from to get this equation right here. The period is 2 pi over 0.5111 because it's 2 pi over B. And if I did that in my calculator, just to show you what they did, 2 second pi divide 0.511, enter, it's approximately 12.29. They rounded to 12. So that makes sense because there are 12 months in a year, and you would expect this pattern to continue the following year. So that's our period, 12 months. Repeat, repeat, repeat. Okay, so now that I've done that, numbers 21 and 22 are the exercises for this example. Okay, so that brings us to the end of chapter 9.6. It's a short lesson. There's only 4 examples. And so it's a small set of numbers that I want you to try. 36 and 39 are review. Thanks for watching and have a great day.